Association of all computer science teachers. Very nice to see you here.
Same
Thank
here,
you
ma'am.
for joining, sir.
Thank you so much.
Good evening, sir.
Very good evening. And thank you for the invite, Dr. Bhakti. It's a pleasure joining.
Pleasure is all mine, sir. Thank you so much.
Excuse me, sir. I sent request for a recording. Please accept that.
Yes, I've accepted.
Yes, Priya ma'am, you can do the stop sharing.
Yes, ma'am.
Can you please put Dr. Mrs. Jayashree, Madam,
No,
on
it's okay.
panel? Take her on panel. And Mahesh Shetty sir also.
And I request everyone to please keep your mic on mute mode while you're not talking, so that the speaker or the others will not get disturbance during their speeches. So it's a
Put
request
them
for
on mute.
everyone.
No,
Please
put
keep your
them on
mics
mute.
on mute.
From your side only you put them on mute. Any panelist can speak. Put them on mute. Everyone.
So I think Mahesh Shetty sir has also joined.
Yeah. Take him on panel. And Jayashree Madam also. And Akshay has joined. So take him also.
Jayashree madam, have you joined? Yes, yes. Jayashree madam has also joined. So I think it's 1831. The participants number is 29. What shall we do, ma'am? Shall we wait for some more time?
Let's start right time. 5:30, 6:30, 6:30. Already
Okay.
one more. So you start. They will
Okay,
join.
fine. Yeah,
No
sure.
problem. But take Mahesh Shetty sir and Jayashree Madam on panel.
They
You
are.
can
They
see
can be,
them.
ma'am. Once they turn on their video, they can be visible. They are visible. Everyone is on the panel.
Okay, then go ahead.
Good evening, Dr. Abha madam and Dr. Bhakti madam. I'm here.
Yes, yes, ma'am. Good evening, ma'am.
Yeah. Okay,
Okay.
thank you, thank you.
So with kind permission of our founder and respected people from IIPT, founder of AACST, Dr. Abha. Here I am Dr. Bhakti Rajvaidya from GH Rasini College of Engineering, Nagpur, and your convener and of course host for the 5 days, starting this national workshop on advanced computational tools for physical sciences, NWACTPS 2026, which is jointly organized. The concept was from AACST, and the supporting role is of IIPT RC08. So I'm thankful to both of them. The workshop is going to be held from 9th of March to 13th of March. That is for 5 days. And I welcome all the dignitaries and the participants for this workshop. So to tell you some more things about the workshop, I have just made a small calculations, since the workshop is all about computations and statistics. So this is my way of thinking of this workshop. The workshop is one concept, that is NWACTPS 2026, two organizations, AACST and IIPT, three guiding forces, Dr. Abha Khandelwal, founder of AACST, Mahesh Shetty sir, president, IIPT RC08, Dr. Rajesh Nibas, secretary. Then our four fields to be discussed here: physics, mathematics, statistics, and computer science. The workshop is for 5 days, 9th to 13th. Five topics. That topics are physics informed neural networks, PINs, then computational luminescence, computational methods in optical trapping, photonics, then density, functional theory, DFT, and Monte Carlo methods in physics. We have 5 session chairs, which are going to be experts for the session and summarizing the session at the end. Today we have with us Dr. Srinath, who is Advanced Research Scientist in Honeywell Technology Solutions, Bangalore. Then tomorrow we'll be having Dr. Vikrant Ganvir, HOD in Department of Physics, Yashwantrao Chauhan College of Engineering, Nagpur. Then we have Dr. Akhilesh Ugle, in charge of Registrar and Assistant Professor in Physics from GH Rasini College of Engineering and Management, Nagpur. Then we have Dr. Jyoti Bushe, PGT Physics, PICT Model School, Balewadi, Pune. Then Dr. Nilesh Ugemuge, Assistant Professor, Department of Physics at Anand Niketan College, Varora. So for 5 days, we have 5 chairs. Then we have 6 persons putting lot of efforts in this workshop. 5 of them are the resource person. Dr. Akshay Joshi from Government Dungar College, Bikaner, Rajasthan. Dr. Amol Nande, Guru Nanak College of Science, Ballarpur. Dr. Praveen Parthasarthi, Dr. HN National College of Engineering, Bangalore. Dr. Priya Mathur, who happens to be the speaker for the day, from Purnima Institute of Engineering and Technology, Jaipur. Then myself, Dr. Bhakti Rajvedya, GH Rasini College of Engineering, Nagpur. And of course, the tireless effort of Dr. Jayashree Bagwade, Treasurer of IIPT RC08. So, after all these statistics, I have few more numbers, like 9 states are there while considering the participations. The 10 hours total of learning and 50 plus participants received so far. The number might have gone above. I have not checked recently for last 2-3 hours, but I'm sure the number has must have reached 60. So now, before we move towards our expert speaker of the day, I would request to open for the opening remark the founder of AACST, Dr. Abha Khandelwal, madam, to please brief us about the workshop and her idea little bit more. Over to you, ma'am.
Thank you, Dr. Bhakti. When physics meets computation, discovery accelerates. And today we are here to experience exactly that. Today, on 9th March 2026, the first day of this workshop, a very warm good evening to everyone joining us from the country, from Nasik, Pune, Chhatrapati Sambhajinagar, Mumbai, Solapur, Bangalore, Kolhapur, Nagpur, Thane, Hubli, Raipur, Gurugram, Rohtak, Bikaner, Bhubaneswar, Jorhat, Itanagar, and many other cities. Truly reflecting the national spirit and academic diversity of this workshop. It is truly a pleasure to see such an enthusiastic gathering of academicians, researchers, and learners united in this academic journey. I feel privileged to extend my heartfelt welcome to our respected chairperson, Dr. Srinath, Advanced Research Scientist, Honeywell Technology Solutions, Bangalore. Our distinguished resource person, Dr. Priya Mathur from Jaipur, the President of IIPT RC08, Shri Mahesh Shetty sir, the Treasurer of IIPT RC08, Dr. Jayashree Bagwade, Madam, and other esteemed dignitaries from IIPT RC08, respected life members of AACST, our valued academic colleagues and research scholars. At this moment, I would also like to especially acknowledge our dynamic convener, Dr. Bhakti Patankar Rajavedya, who has truly left no stone unturned in coordinating and Hello?
Sorry to disturb you. Is
Yeah.
it working?
Yeah, it's working, madam. We are.
Yeah.
If it would be better if you can join us, yeah.
I
If
will just
possible.
see. Yeah,
Okay.
I'm reaching in 5 minutes.
Yeah, okay. Thank you, ma'am.
And
It's on, ma'am.
no
Yeah.
problem. Sorry, there was a meeting at Mumbai Savarasi. That
Yeah.
is why I went to that proper.
Yes.
You just carry on in
Yeah.
between. If I can join, I will
Please do so.
in
Yeah.
the end at least. How long it
Okay.
will go on?
8:30 up to. So you can join up at 8 p.m.
Okay.
Oh,
8:15 I will join them. Okay.
Thank you.
Yeah,
Dr.
thank you.
So this was General Secretary of IAPT. So I really welcome her too, and she's going to join us at 8 p.m. And I would like to take a moment to especially acknowledge our convener, very dynamic convener, Dr. Bhakti Rajavedya. She has left really no stone unturned in coordinating, executing this workshop with remarkable dedication, meticulous planning, and a clear academic vision. So kudos to you, Dr. Bhakti, for that. And the purpose of this workshop is to create a platform where physics, computation, and modern scientific approaches converge, enabling participants to explore emerging tools that are transforming research and teaching in physical sciences. So today we will begin in this journey with a fascinating topic, physics-informed neural networks, PINs. This innovative approach integrates deep learning with fundamental physical laws, offering powerful way to solve complex scientific problems and opening a new dimension in AI-driven computational physics. Dear participants, you are not here merely to listen, just to attend. You are here to explore, question, imagine, experiment, collaborate, innovate, and transform the way science is understood and taught. So workshops like these serve as catalyst, sparking ideas, building collaboration, strengthening our collective research and teaching practices. So I encourage all of you to engage actively, interact with our experts, and make the most of this unique opportunity for learning and intellectual exchange. With these words, I once again extend a very warm welcome to all our participants as well as respected chairperson, resource persons, our president of IAPT RC08, treasurer of IAPT 08, RC08, and everyone over here. And thank you and welcome once again. Over to you, Dr. Bhakti. Thank you.
Thank you so much, ma'am. Indeed, thanks to you for offering me the opportunity to be the convener of this workshop, because topics are so catchy that no one could stop themselves from getting registered, enrolled in this workshop. So really, really many thanks to you. And now I would like to request Dr. Jayashri ma'am, to say a few words as a remark, or we can say the opening remarks for the workshop. So over to you, Jayashri ma'am.
Okay, thank you, Dr. Bhakti Madam. Good evening, everybody, respected dignitaries, esteemed guests, and distinguished participants, and dear colleagues. It is with great pleasure and sense of profound responsibility that I welcome you all to this prestigious national workshop on advanced computational tools for physical sciences on behalf of our IAPT, RC08, and AACST. This event, organized by the Association of All Computer Science Teachers, as already said by Dr. Abha Khandelwal Madam, in collaboration with the Indian Association of Physics Teachers, IAPT RC08, which marks a significant milestone in nurturing interdisciplinary synergy between computer science and physical sciences. In the rapidly evolving landscape of science and technology, dear participants, that is, computational tools have become indispensable in unraveling the complexities of the physical universe. From simulating atomic interactions to modeling cosmetic or also the cosmic phenomena, computational methods which empower researchers and students alike to explore, innovate, and discover beyond traditional boundaries are here. And we all know that the IPT has been always at the forefront of promoting excellence in physics education across the country. Its activities include organizing national and regional conferences, workshops, and training programs aimed at enhancing teaching and methodologies, encouraging research, and nurturing collaboration among physics educators and students. IAPT initiatives also inspire young minds to pursue scientific inquiry and equip educators with innovative pedagogical tools to make physics more engaging and accessible. This workshop is, as told by our convener, Dr. Bhakti Madam, is designed to serve as a platform for postgraduate students, research scholars, and faculty members to gain exposure to cutting edge computational techniques, learn about the latest AI driven data centric approaches, and strengthen the research capabilities are here. The key topics covered here, which are very excellent, that includes a digital Fourier transform, then computational luminescence, optical trapping, physics informed AI, and Monte Carlo methods, which are crucial in advancing our understanding and teaching of physical sciences. I encourage all the participants to actively engage in the sessions, share your experience, and ask questions. Remember, such platforms are not just for learning, but also for building networks, fostering your collaborations, and igniting innovative ideas that can transform science and education. Let us leverage this opportunity to deepen our knowledge, enhance our teaching methodologies, and contribute meaningfully to the scientific community. IAPT's ongoing activities and your active participation here are at vital in shaping the future of physics education and research. I extend my great heartfelt gratitude to the organizers, then the speakers, and all the participants for their dedication and enthusiasm. I wish this workshop great success and look forward to the fruitful outcomes it promises on behalf of IAPT RC08 and all the dignitaries. Thank you so much. Wish you all the best, Dr. Bhakti Madam, Dr. Khandelwal Madam, and thanks for the nice opportunity to give me the certain few words or inaugural address for the same. Wish you all the best once again, all dear participants and all the organizers and conveners. Thank you. Thanks a lot.
Thank you so much, Jayashree ma'am. So moving further, we can see 40 participants have joined yet. So I hope they all will be joining soon as we begin with the actual session. Now, before we go to the speaker directly, let me take this opportunity to invite our today's, we can say, the session chair, the person who is going to chair the session, summarize, or we can say moderate the session actually, and at the end maybe having some questions or summary of the session presenting before you. So, Dr. Srinath, I'm very happy, sir, that you accepted the invitation and joined today. Dr. Srinath is advanced research scientist at Honeywell Technology Solutions, Bangalore. He is having a very rich experience of, we can say, his throughout career as a teacher or maybe even as a student. He has done his PhD in aerodynamics from aerospace engineering from Indian Institute of Technology, Kharagpur, and then he is having an experience of 9 years as an assistant professor in mechanical engineering from NIE Mysuru, and then the industry experience of 5 years in L&T and Honeywell Technology Solutions. He is having also 7+ years of research experience at IIT Kharagpur. Then he has also been involved in the very key projects. Some of them are mentioned over here, like design and development of nozzle assembly for India's largest hypersonic wind tunnel system, commissioned at Vikram Sarabhai Space Station, VSSC, ISRO, Thiruvananthapuram, and performance prediction of Kaveri engine combustor for gas turbine research establishment, GTRE by DRDO. Few more projects from DRDO, and also from some foreign projects are listed over here. So you can go through his very, we can say, enriched slide. And at the end, he is also the award winner at many stages of his life. So we are very, very happy to have you with us today, sir, as a session chair. And now I will hand over the rights to you completely so that you can brief about today's speaker and then ask her to go with her session. So over to you, Srinath sir.
Thank you very much, Dr. Bhakti, and thanks, Dr. Abha and Dr. Jayashree, for properly, nicely introducing this particular platform, the research objectives, as well as the topics that are of immense importance to all the researchers in this particular domain. And coming to this particular session, this topic happens to be one of the most sought after topics in the area of research. So we are very privileged to have Dr. Priya Mathur with us. She is a research faculty in the Department of Mathematics, Purnima Institute of Engineering and Technology, Jaipur. She has a rich experience of over 23 years in academic as well as administrative experience. Her research domain has been fluid mechanics, which also happens to be my area of interest. She has more than 60 plus Scopus Index publications, authored more than 4 books, filed 2 patents, and has a rich and diverse research experience in the domain of nanofluids and dynamics, heat and mass transfer, hydrodynamic stability, biomathematics, and computational mathematics. I'm sure the session by Dr. Priya Mathur is something that we all seek to attend to keenly. I think the next 2 hours are going to be richly informative, and we look forward to it. Over to you, Dr. Priya Mathur.
Thank you so much, sir. So shall we start?
Yes,
Yes, you can
please.
start, please.
Okay. So the presentation is visible?
Yes, full screen. Yeah.
Okay.
Go
Good
ahead.
evening, everybody. And I thank you, everybody, for this nice arrangement of this FDP. And this is my privilege to be here and guiding a few fellow researcher or graduate and postgraduate students. So I have just make a presentation according to the student, those who are studying in PG classes or the freshers who are just going for research. So PIN is one of the most important topic nowadays because every problem which we are facing or we are making in mathematical modeling converted into a differential equations. No doubt either it is wave equations or any sound equation or any other equations or problems in optimization, we have the differential equations. So solve the differential equation and get a perfect answer is very difficult. So nowadays we are using so many tools. MATLAB is there, and uh, MATLAB results are also validate the original result. But when we go to the some AI tools, then we have to look for some better solutions and futuristic solutions. When we use the only machine learning tools, it has some limitations. So I start my session about to tell the basic of machine learning, then why we shifted it to PINN, and then I try to explain ordinary differential equation and partial differential equation. How can you solve by the help of PINN? So I'll give you some small programs to solve these equations. So let's start about the introduction to machine learning. So we all know nowadays the definition is very simple. Introduction of machine learning. We are trying to learn the machine. Machine learning is teaching computers without explicit program. It learn from data to make prediction mainly, and it is a part of artificial intelligence. So basically, there are three type of machine learning. First is supervised, unsupervised, and reinforcement learning. Supervised learning uses labeled data to train the model. What is the labeled data? Means we have already labeled the data like the pictures are of cat, dog, or train, or leaf, or any kind of a pictures is there, then it is called a supervised learning. Non-supervised learning find patterns in the unlabeled data. When you give the data to the machine and wo itself machine find the pattern into some data, and then it itself classify that thing, that is clustering and dimensionalization. And the reinforcement learning is little different, trains agent to make decision in an environment. So गेम में जैसा आप देखते हैं कि गेम में screen can change by the decision So this is type of learning is reinforcement learning. So what is supervised learning? The input are the images. So we can give the input in the images form. We can give the images like dog, rose, or any other images we have as a input data. We give to that machine and learn machine from that input. Then we make a neural network for this data. Machine learn from that input data and itself predict for the it predict from that data only. So what if I don't have many labels? Suppose we have a very small data. We have a very small data in terms of like there are not so many labels. Then how can be a prediction will be good? So, in terms of your physics problem, if you want to talk about that, then like Newton's law or heat equations, if we have such type of data, then what about the supervised learning? Will it give the good answers, good predictions to our problem? So, what is PIN actually does? So, it is a type of it is type of a supervised learning. In supervised learning, we train with data point and labels. But in PNN, you turn you train the with data points like location, time, name, anything else. Instead of labels, you are physical, and we can also use the physical laws. We can give the equation and we can also predict the solution of that equations. So, a physics informed neural network is a neural network that learns solutions to differential equations by embedding the physical laws into the loss function. So, I will explain how it works. So, you just tell me, uh, suppose we are taking a very small physical example. You all can hear me now?
Yes, you're perfectly audible.
Okay. So suppose let's say you have a ball and you are just throwing a ball and you take the points at what time the ball's position is at what height. So this is a very simple example. You have a ball and you throw a ball and you are plotting some points at what time your ball was what height. Okay. Now let's say you are making the graph at 5 second, 10 second, 15 second and 20 second. You draw that graph and now you want at if on the 11th second if your ball will be on the top, then at what height it would be. So how you can predict that? So in if we have a very small data, we learn the machine will predict. Machine will predict exactly at what time, exactly 6 second, 5 second, 8 second, at any time what you want to be assumed. Then suppose that height is predicted by the machine is very far from your calculation or it is far from your physics law. You are getting my point? Means the physics equation is telling something you else and your prediction value are something else. There is a huge difference between these values. It is like ki, suppose today's petrol price is 104 rupees. Next day price is 105 rupees. And after 15 days, you try to predict with the machine what would be the prices. But you are not giving any physical law. You are not giving any idea to machine what is happening in the environment. So how could machine predict that value? It will predict because of the previous data, not by the environment, not by the law of physics. So maybe your machine will predict कि it will goes up to 105 rupees only because there is no change in that any other things. But as the war is going on and the practical situation is saying it will goes up to 150 rupees. So it is not we can assume by the machine learning because environment friendly nahi hai wo. Then if we work through the physical laws, if we give the environment, then PINN will give you the exact answer. So the predicted value and the actual value, there is a difference between these two, and that is called error. So in that, we try to reduce the error and we make the prediction very fine. So what are the main difference between these two machine learning approaches and in the PNN? So the first is input. In machine learning, we are giving the image pixels for the training data. In PINN, we are giving a space-time coordinate. So you are giving X, Y, and T, and any other according to your equations or your environment. Output, what we receive output in the label diagrams or labeled out ways. And finally, in PNN, what we find? We find the field values like temperature, velocity, pressure. What kind of equation we give for the training? We find that answers. Then the learning sources in ML, it is labeled data, and in the PNN, we can give that physics law. We can give the equations. We give the condition. We give the situations and the loss function, cross entropy, mean square error with labels. But here, partial differential residuals plus boundary and initial condition losses goal, classify correctly, and here is the goal is satisfy physics and match spare data. So these are the basic difference between the ML and the PNN. Now, briefly, what can say? You are very, you are very children. You were children. So if the data is given to that and the assumption and prediction we receive from that, it is very small. So it is in the term of the label, like you are a children, your dog, and that kind. You learn to identify dog by seeing many of them. That was data driven learning. Means you have given the pictures to the data and it will learn from that. Later, you learned about bones, muscles, and motion. That's physics. PNN are like scientists. They don't just memorize, they work with the equations. So now we come to the PNN. Why PNN is so important? And comparison we have already discussed. So in this session, what I have to cover, the introduction of PNN, neural network basics, limitation of data-driven models, physics-informed neural network, mathematical formulation, algorithm and flow, workflow, example of partial differential equation, application in engineering, application to heat transfer and nanofluids. So what are the motivation behind that? Many engineering systems are described by differential equations. Example includes heat transfer, fluid mechanics, and electromagnetics. Solving these equations accurately is essential for prediction and design. What are the traditional method? Finite difference method, which is a very common method to solve the differential equation. The second one is finite element method, which is again useful, and we can do programming in MATLAB and Python also. Finite volume method, spectral method, the technique discretize the physical domains. So these are the method to solve the differential equations or couple of differential equation, not a single equation. If we will have a system of linear equation or non-linear equation, we can solve by these method. So what are the limitation of classical methods? High computational cost. It will take a lot of time to program that. Require of fine meshes, difficulties in high dimensional problem, complexity of irregular geometries. Emerges of scientific machine learning. Scientific machine learning combines machine learning, mathematical modeling, physics law. It enables new approaches for solving differential equations. As a mathematician, I've had to solve the differential equation for any kind of a problem. So my emphasis is to get a very best solution without doing much efforts and the most suitable solution with the minimum error. So I prefer this PNN. A neural network is a computational model composed of layers of neurons. It learns complex relationships between input and output variables. Basic neural network structure. Input layer, there is an input layer, the data, the inputs we are giving. Then in between, there are the hidden layer, and the last one is output layer. We will discuss later on in detail. Hidden layer perform non-linear transformations. So we have a very small example of that mathematical model for neurons. Excuse me, because I'm not well. So excuse me for this disturbance. So we have a neuron like y equal to sigma wx plus b, where w is denoted as weight, b is for bias, and sigma is activation function. Then what are the common activation functions? The common activation functions are sigmoid, 10H, ReLU. They introduce non-linearity into the model. Training a neural network. Training adjust what training does actually. Training adjusts weight and bias to minimize a loss function. Optimization algorithms such as gradient descent are used. Optimization algorithm के लिए what we are using the gradient descent technique. Limitation of pure data methods. Large data set are required to train the model. So, idea behind physics informed learning. Instead of learning from data, we incorporate physical laws into the neural network training process. A physics-informed neural network integrate differential equations directed into the loss function. So what does PNN actually do? We will explain in that. Assume the solution of PDE partial differential equation is approximated by a neural network. The function is u x comma t is n, which is a neural network. Neurons के लिए n x comma t theta represent trainable parameters. So I will explain this. So what automatic differentiation neural network framework compute derivative automatically? We are not able to do that. It is automatically in the program. This allows calculation ut and w. Ut means the first derivative, and uxx needed in partial differential equations. Partial differential residuals are the residual of the governing equations is defined as f of x comma t ut u underscore xx. The network is trained so that f of x comma t approaches 0. The loss function is total loss function is defined by PDE loss plus boundary loss and the initial condition loss. I will explain all this. What is partial differential equation loss? What is boundary condition loss and what is a initial condition loss? I will explain all these three type of losses and the total loss. What is these are the basic terms which we are using in PNN, the loss function and the collocation point. What is collocation point? Random points inside the domain are selected. These points enforce satisfaction of PDE. We can choose that collocation point like 200, 500. For the better, we need so many points in collocation. Training workflow, define governing equation, build a neural network, generate training point, compute derivative, calculate residual, minimize loss, and predict the solution. These 7 steps we have to do in the PNN modeling. Define governing equation. First, we have to give the equations, then build a neural network, then generate training points, compute the derivatives, calculate residual, and minimize loss, predict the solutions. What is architect of PNN model? Input. The first is input layer. Then the second is hidden layer. Input layer means we are giving the equations for the input. Then hidden layer, where the working is going to be done in the network. We can choose that hidden layer. It may be 2, 3, 4, 5, 6, 7, 8, 9, up to 1000. As we want the solution very perfectly or precise solution. Output, the predicted physical variables are as output. So what we need input initially x and t. Neural network predict u function value, predict it will predict the functions value, derivative computed, partial differential equation residual evaluated, and loss minimization. What are the advantage? This is mesh free, work very well. We have already discussed so many things with this. So application in fluid, it is used in Navier-Stokes equation, boundary layer flow, turbulence modeling, heat conducting, thermal diffusion, and solid mechanics में elastic deformation, stress analysis, material modeling, Maxwell's equation, wave propagation, electromagnetic field simulation, application in nanofluid heat transfer, boundary layer modeling, radiative heat transfer, and magnetohydrodynamic nanofluids flow, entropy generation, and these are the future of this. So let's take an example, and now we are going to understand how it works. Whatever I told you earlier, it is just the basic what terms we are going to use to understand the PIN. So let's say it is a partial differential equation. Ut equals to c square uxx. X belongs to 0, 1 and time is greater than 0. Ux, t represent the temperature. C square depend the thermal diffusivity. Boundary conditions are, why boundary conditions are very important, I will tell you. Boundary conditions are at x equals to 0, the u will be 0. At x equals to 1, u again 0. And what are the initial condition? Means in a very beginning, temperature is given by the sine pi x. So how x changes? The initial condition changes. Let's say this is an example for the equation. So why boundary condition and the initial condition are important? We come to that point. So I gave you an example. We are throwing a ball. Suppose you are throwing a ball and you don't know at what height initially you throw it. So when you predict the values at different time, you never know how much height it takes. Means if you don't know the initial position, how can you guess up to what height it goes up to? The difference you can't measure. So initial condition is very important. How it goes up to, कितना वो दूर तक जा सकता है, ये पता करने के लिए initial condition from where it is started. We need the initial condition. And boundary condition, up to what boundary it has to be go, we have to decide for the very precise solution. If we want physical, if we are applying some physical law, we are having some particular case, then initial and boundary condition are very important for the perfect solutions. So when you are having a total loss, and what is the total loss? I tell you now. Suppose there are two things. One is the experimental values, and second is the physical loss values. And now I will tell you the difference between these two. The first is data experimental data means you are throwing a ball and you are collecting a data, or the experiment is going on and you have collected a data. When you are having a data, the data must not be very clean. Maybe it is not clean. In which environment the data has to be collected, you don't know. What physical law applies to that time, you don't know. What are the conditions, you don't know. You are predicting for the future because of that previous data. So now, when you predict future values or you predict in between values, there may be a huge difference. That is called the error. But when we are not using the initial and boundary condition, the error is in between the predicted value and the formulated value, or the experimental value is too large. And your loss function is very high. But when you take the boundary condition, your loss and initial condition, your loss will be very, very less. And we are taking it square. Means I will tell you how we are taking it very small so that error is minimized or optimize the solution. Traditionally, we solve this with finite difference or FEM method, but what if a neural network could learn from this solution? So, ordinary neural network and how the PINN or PIN भी हम इसे बोलते हैं, PIN different from these two. Learn from data x to y, it learn from the differential equation. It use the labeled data, it use the physical law, need lot of data. It is needed by a single equation. It just said a single equation, you give it and it will calculate everything. So loss predicted minus label, just having two values there, predicted value and the label value. But here residual square plus boundary condition or initial loss. So your loss is very small here. Learn from the equation and it is learn from the data. So we are having, assume a given data is xi into yi, there exists a relation x to y. Supervised learning, given training set xi comma yi, xi and yi, we give that. Find x to y, good approximation of that. And what is a mean square error? It is a square of that predicted value minus the labeled value or the actual values. So it is given by En equals to 1 upon m. The number of data is available. Summation I 1 from to m. If suppose you have 10 data, so it is from 1 to 10. If you have 200 data, then it is from 1 to 200. Yi minus Pn predicted values. Yi means experimental data or the data you have already collected minus Pn xi square. That is called a, why we are taking a square? So if we are not taking it a square, the values are very high. The error is very high. And suppose sometimes the error is positive, sometimes the error is negative. Sometimes the error is positive, sometimes the error is negative. So when we total, we sum up all the error, it will be zero or it will be not actually showing the error. You're getting my point? Means, suppose we have 10 data. 5 are the negative errors and 5 are the positive error. मिलकर क्या हुआ? All are sum up and the net result is zero. That's mean your predicted value and your experimental value are same. But no, graph is not showing the same thing. These two things are different. You are seeing the different thing, but your values are different. So this means it is not sufficient. Okay, that's why we are taking a square of that. So that either the errors are negative or it is a positive, it will all contribute in that error function. So physics informed neural network are basically neural network that try to learn a solution while also following the physics rules. The main concept of PINN, which is not rely on the data, but also the also it's convey or guided by physical properties which define how the system behaves. The PINN has introduced by Rasai and colleagues a very famous paper, and afterward PINN become popular in the field of research to integrate the machine learning with scientific computing. So now take a very small example. Now you all have a very small differential equation. We are taking up first order partial differential equation. So suppose you have an equation, and when you are, because we all are from mathematics background, so when we are going to solve this differential equation, what would be the answer? Ux equal to e raised to minus x. This is the solution. In order to approximate this function, PNN architect that utilizing the both data and physical constraint during training process to provide the solution. Look at this solution. We have the simple solution like this, and the initial condition are also given to us. Okay, so simply we can solve it. How the neural network do it? I will explain how do it theoretically first, and then we go to the collab, and I will give you the program, then how it can learn. So neural network, you get x comma theta with trainable weight and biases theta. Theta is bias, is used to approximate the unknown function ux. Instead of relying on the labeled input output data, we are not giving the value of x. We are not giving the answer to the function. We are just giving the equation. So neural network approximation, u cap equal to u comma theta with a neural network that represent the function that is unknown using automatic differentiation. It is possible to calculate the network output derivative with respect to x exactly as follows. You just look at this. Then the total loss function is designed to penalize both the violation of the governing ordinary differential equation and the initial condition. So L is defined as a loss function. It is equal to loss for partial differential equation plus loss of IC. IC means loss for initial condition, where LPD is 1 upon NF summation I equals to 1 to, this is for the iterations, R F comma theta square, and this is for the loss function of initial conditions. The optimization process involves minimization L theta with regard to network parameters using gradient-based optimizers such as ADAM. So ADAM is for the optimization which we are using. The PNN learn an implicit representation of UX that satisfy the ODE and the initial condition. As training advances, the residual R theta x comma theta approaches 0, driving the neural network output towards accurate physical solutions. So up now we come to the code part. What we can code, or what are the basic things, what kind of a libraries we have to import for this purpose. So import libraries are import torch.nn, as nn we can name that, torch dot autoguard as autoguard, numpy as np, and matplotlib for plotting the graphs. Torch is the main PyTorch library used to building and training the neural network. This is the first key which library we have to import. The torch, and the name we put for a torch is .nn. Torch.nn provides tool to define neural network layers, linear layers, or 10H is for the non-linearity. It will convert the non-linear into the linear part. Torch.autoguard enable automatic differentiation used to compute derivative essential for enforcing the differential equations PNN. NumPy used for numerical data and plotting for the next. So how we call them? First, we write that class PNN bracket nn dot module. So first we define that modules, define underscore, and these are, I will give you that code also so that you can also go to that. So I request you all the participants, you just go to the Google and right here Colab. Go to the Colab. Welcome to the Colab. You just click this and your notebook will be open like this. You can initially this and you can test here and code. So you can code here. Can you all see this?
Yes, ma'am.
Okay, so I request you all the participants, please go to the Google and type Colab. And then go to file and just have a new notebook in Drive. So your notebook will be open like this. So how we can look at this program, what I told you, we can import the basic file. You just, so look here, I write here import torch. I explained you why the torch is important. It is for the so just go to that slides again. Why we are calling all the libraries. The main PyTorch library used for building and training the neural network. Remember it, why we are. So here what we are doing? So first we import torch. Paste, or you can write in your program.
Dr. Priya, copying and writing down will make no sense. You just explain and execute this, and
Okay,
later
ma'am.
you can put everything, all these commands in
Huh.
group, and then they can do.
Okay, okay, ma'am. Okay, ma'am. Fine. So first we import the torch. As we have explained, the torch is the most basic for the neural network building. Then import torch.nn as nn, means we are giving the name. I have, the second library is very important. Torch.nn provide tool to define neural network layers. It is for the layers. So second one is torch.nn. And then third one is Third one is torch.autoguard. What? And we are saying, call it as a autoguard. Why it is important? It is important because enable automatic differentiation. NumPy for the numerical calculations and plotting for this. So NumPy for the numerical calculation. So first of all, we have to define a neural network. So how we define the neural network? Class PNN nn dot module. I will give you the program. You can paste and you can learn from this program also. I will explain why I am writing this and how it works. So these all are the common terms in the programming. Basic programming part ही है ये. So you need to learn basic Pythons for it. Super. These are PNN.self. These are the basic lines. ये सब. Then nn.linear. So how many layers I am taking? 32 at a time. So you can change it up to what level? 30, 13, whatever. So I am taking it 32. You can take it more also. So 1 comma 32 means the input is 1 and the 32 hidden layers are there. nn.10h. Why I am using the 10h means if there is some linear function, then it can convert into the non-linearity, means it will cover that point also which is not coming into the that predictions. Means suppose one prediction is you're out of the point, means you are taking some predictions and they are as near to your calculated value and few values are little far. So machine learning, when we are talking about the machine learning, so they are far away points in the fitting of a curve. We can leave that. They are outliers. We can leave that point. But we don't want to leave that point here also because we are calculating in a physics. So why they are too far? Why they are go away from the normal solutions? We also need to include in that. That's why we are having a 10h here. Then linear, again, these 32 1. nn dot linear 32 1 means after this 32 hidden layers, output must be 1. So we are not watching 32 solutions. We are having only one output. Then forward, return to this, define the physics informed loss. Come to that point. PNN loss model XF means loss for a function. XBC loss because of the boundary condition, and it is loss for the initial condition IC. Physics residual, what was our equation? du over dx plus u. अब आपका इक्वेशन कुछ भी हो सकता है. आप अपना इक्वेशन यहाँ पे लिख सकते हैं, whatever is your equation. So we can define it. XF requires XGuard, and these are the basic programming part which you can copy and paste same. Then we define the boundary condition also. Loss, what is loss? Loss equal to torch dot mean u underscore bc underscore predicted value minus u underscore bc square. That means it is a mean square error. So this is loss for boundary condition. So return to loss for the equation plus loss of the boundary condition. This is for total loss. Then training data, what we are going to giving for the training. Access torch dot lin space 0, 2, 100. So we are taking a 100 values. You can take up to 200. How many values you take? It will give you the best answers. Means 100, what we can say, the more approximation you are taking, the more precise solution you will have. So we can take more 200, 200, 300, up to that. Rephrase -1 to 1. These are the basic for torch dot tensor. These are the basic. You can copy and paste there. No problem. Model we are choosing PNN. These are the rules. Then epoch. What is epoch? I am taking the epoch 5000. Means the first answer comes for me. Then again it will go for the training. Then it is coming. Then it is going. Then it is coming. 5000 times the loop is running. So how many times the loop is running? The answer will be very precise, very good answer. The error will be minimized. So I am taking the epoch is 5000. So in this case, you can check or you can take any kind of value 500, 200. But going more approximation, more values, more epoch, you will have a more good answers. Then these are the optimizer dot zero grade loss is PNN underscore loss for model fx boundary condition for x and boundary condition for u. These are the epoch values. Then evaluation x underscore test torch dot linescape 0, 2, 0, 100 rephrase. These are the values. Then visualization. So these are the again coding part. These codes are available. Very simple codes available for the Python. These are simple code or it will run easily. So PLT dot figure. It represents that we are going to plot the figures. Plot dot figure. Figure size 8,5. You can change the size also according to your requirement. PLT dot plot x underscore text u underscore true. R and red means what we are going to create a line in a red color. So it is R. If you want to blue, then you can take it blue. If you want to take it yellow, you can write it Y. Or any other color, you can check what what you have to write here for your specific color coding. Plot plt dot plot x test u did ये टेस्टिंग के लिए लिखा है मैंने इसीलिए टेस्ट लिखा है इफ इट इज नॉट रिक्वायर नीचे वाला जो ग्राफ लिखा है इट इज दिस इज फॉर आवर सोल्यूशन सो व्हेन यू राइट द प्रोग्राम you run all so when you run all the graph is automatically comes here it is for the y it is for so wait I run it again. So you can also solve the couple of equations, not a single equation. You can solve the 1, 2, or 3 equations at a time, and you can plot a number of graphs, many graphs at a time in the different parameters. Initially, because this is a very initial session, so I am taking a very simple equation. But because as my fluid is there is a momentum equation, means velocity equation, then temperature gradient is there, then concentration is there. So there are 3 equations. So we paste all 3 equations in that and we have a solution for all those 3. So these are the basic of the program values. So I am writing here why we are choosing this nn dot linear 1,32 input layer with one neuron going to 32 neurons. So that 32 which I defined in the program is 32 neurons I am taking. You can change it. You can take it 40, 13, any number you choose it. Then NN.10H activation function to introduce non-linearity. Why non-linearity? I have told you because we have to cover that point also, which is far away from the solution, or this is they are not coming in that part. Then another linear is 32, 32 means 10 hyperbolic, that hidden layers means 32 hidden layers are there and they all are non-linearly working. Then NN dot linear 32,1 output layer giving one value, one output we need. That's why it is one output. Then this is PNN loss function. I have defined you in that programming part also. So I'm skipping that. What are that? X underscore F क्या बताता है? It is denoted collocation point inside the domain where the ordinary differential equation must hold true. X underscore BC boundary or initial point where U0 equals to 1. It is given to us initially. U underscore boundary condition, actual boundary value 1 because it is given to 1. So we have discussed that F underscore F 100 means evenly spaced point between 0 to 2. 0 to 2 may we have divided 100 different points. If you want to divide up to 10 points, you can divide 10. You divide up to 50 points, you can divide up to 50 points. Then model initialization and optimizer. This is the code for the model initializer and optimizer. Define the add-up optimizer with a learning rate of 0.01 to minimize the total loss. So I'm taking a very small number 0.01 to minimize a loss. Then training loop. So I'm talking about that epoch or 5,000 I'm taking because a compute fastly and 5,000 means every 500 epoch it prints the current loss for monitoring and convergence. Then again it will go, then again it will go and come 500, fit 1,000, fit 2,000, fit 2,500 up to 5,000 times. So it will give you a very good solutions. Then evaluating and plotting part. So these are the code for everything. I'll share the PPTs also. You can go through this. X test, then create text point X underscore test in 0 to 2. तो हमने क्या स्पैन लिया है ग्राफ का 0 to 2. आप 0 से 1 भी ले सकते हैं. You can take 0 to 1, 0 to 2, 0 to 3, whatever kind of a graph you want to plot as per your boundary condition or your situation. So here, look at this graph. When I run, I will have this graph. So 0 to 2. 0 to 2, I'm taking this blue color line is there. You can check it. So predicted value and final values are same in this. And this is you can calculate the training loss convergence. So you can see up to 5,000 epoch, the loss is very less, means 10 raised to power minus 5, minus 6. That means a loss is very, very small in terms of our solution. So we can just have a look for a small partial differential equation. What we have discussed earlier, it was for a ordinary differential equation. Now I'm taking a very small example of diffusion equation. Del u over del t equals to alpha del 2u over del x square. On the spatial domain, x belongs to 0 to 1 and the time domain from 0 to t. With initial and boundary condition, initial and boundary condition are giving to according to the physics law. That's why we are using this PNN. So PNN giving the solution according to this boundary and initial conditions so that your solutions are very precise and helpful for your findings. Then how we write the PNN formulation for it again, that U cap equals to x comma t theta, then nn x comma theta, U cap t is del u over del t, and U cap xx is del 2 U cap over del x square. This is a double differentiation because it is U cap xx, it is a double differentiation. U cap t is a for single differentiation. Define the physics residual points. R residual is defined by R. X comma t theta U cap x t theta minus alpha, and this alpha is for, in your equation alpha is also mentioned. So what you have created from that differential equation, you have created this residual. I think it is visible, so you can also see this. Oh shit. So now this is the formulation. So now what about the loss function? The loss function is again given by this. You just look at each and every term, and you to understand this basic PNN, you just go to the Rasai et al. Paper. You just paste in the Google Rasai et al. And you will find a fantastic paper of Rasai, who first initially invented this physics informed neural network, which is nowadays we are using firmly because of his research. So you just go through it, and it will give you the vast results also. PD collocation point is R residual for the partial differential equation. This is for PD collocation point. This is the initial condition loss. This is the boundary condition loss. And now we train the training of PNN for PD. So this is a training part. You can read it out. Then again, I will go to these same functions we call again. I'll go to the programming part again of this PD. I'll show you. This is for the partial differential equation, which I have just told you. PNN for the heat equation, U underscore T equals to alpha U underscore XX. This is for the double differentiation. You know, we are defining the double differentiation by this. Initial condition is this, and boundary condition is this. So whatever is given in the equation, we write here first. Then we import the libraries torch.nn, AutoGuard, matplot, and NumPy. Okay. Then we have decided the values of alpha. The thermal diffusivity alpha is 1, NF 2000. The collocation points, how much we are taking a point, collocation point we are taking 2000 points are here. Initial condition points, how much we are taking, 200. Boundary condition point we are taking 200, and epochs we are taking 5000. Then residual IR is up to minus 10 raised to power minus 3. Then up now we are constructing a neural network. So first we define the differential equation. In second part we are defining what? The values, the given differential equation. क्या हमारे पास है? We are defining that values. Then neural network, we are making a neural network for that differential equation. So this is a program, hidden layer, what kind of 10 hyperbolic, and it is same. Same as for the differential equation, you can copy and paste here. Then derivative helpers, gradient, because now it is a partial differential equation. So we have to find out the gradient. So gradient u comma x order 1, because it is del u over del t. So now we have a single order. So we write here that gradient, that data sampling, what we are doing. So here we are writing that the whole program according to our equation. Look at that. What we are making, every line is very precious there for this neural network. Then optimizer, we call them optimizers. Torch dot optima, Adam जो हम यहाँ पे कॉल करते हैं ऑप्टिमाइज करने के लिए, and this is for loss function. Same. Then the training loop, and then you can see the values here. Look at this value. First is 500, 5,000 में से first 5 value. Loss is this, PD is this, initial condition is this, boundary condition is this. Then epoch 1,000, 500,000 में से loss is this, PD is this, IC is this, BC is this. In this way, we go up to the 5,000, and you see the loss is 6.41, 10 raised to power minus 0.5, very less. These all are, and then when I run all, it will give the graph also. You can copy and paste your graph directly to your paper, to your book chapter, whatever you are solving. You can directly use copy and paste graph from here. So you can change the color, code, graph, style, many things. So initially, if you practice that, you can see how it can be changed. So it is taking time because it is too long.
Yes, till the time it is taking time, I would like to also request Priya ma'am. There is a request from the participants in the chat box to share the codes in the WhatsApp
Yeah,
group
sure,
also.
ma'am. I will share the codes also. I just want to paste here also, but ma'am ne रोक दिया. Otherwise, I just want कि student also copy and paste and run these code by themselves. So at least
Or
they
we
can
can have the
see.
code files shared directly. You can share the code
Oh,
files also directly.
okay, ma'am. Okay, I'll share the code file directly.
Thank you.
So again, when you see that, it will be the training loss in the partial differential equation. So the solution is like that. I'll check. अभी इसका ग्राफ तो नहीं आया है. It is taking too much time. But the graph will come like this. And this is the error or training loss, the loss functions. So PNN provide a powerful framework that integrates neural network with physics law. It is not trained by a data only. The raw data, you are not giving that raw data, you are giving your equations, and it is trained by that equation. It solves that equation by itself, and then making that solution. So the solutions are very useful for us for the physical solution. Physical solutions, are always important rather than the data, matlab predictions from the data. So data is not much reliable. Maybe the experimental data is not all time sufficient. So thank you so much. This is from my side. It is to, fast forward way. Uh, so it will take time to understand the code and how to write the code. But there are so many tools. The Python is very easy to understand. So you can also learn by yourself by small programs. So slowly you can learn. Yes, ma'am.
Thanks a lot, Dr. Priya Mathur. This truly was a stretched effort, and I understand that you have put in a lot of hard work to get these slides ready. And speaking over the duration of the last 1.5 to 2 hours is not so easy, especially in an online platform. And on top of this, having this health condition and still you made it, it really
Yeah,
means a lot.
because I'm not well actually. Last 2, 3 days I'm suffering from throat infection and fever. So it was very difficult for me to speak. So I'm just praying that at least I can deliver what I want to actually deliver for the students.
Absolutely. I think you have done a full justice to the content that was provided. You started off with a brief description of machine learning and how pins are different from that, and also gave clear examples on where
Master,
is this applicable.
may I interrupt? Let's
Absolutely.
open the session, question answer session first, and then remarks.
Yeah, sure. Session is now open for.
I have a query, ma'am.
Yes.
Then you can put in chat.
Can I speak?
Yes, Dr. Priyoshi, both if you can put the query in the chat or you can directly ask. Anything is okay.
Yeah, okay. Thank you so much, madam. It was a nice session, although we did not have any background of Python, so it was a little difficult for me and two of my colleagues who have joined this session to understand what is basically going on. But then I have done a few of calculations during my PhD work. I just wanted to understand that when we are giving epoch as 5,000, is
Hmm.
there any way that there could be a point where error can increase in between, or is it always that the error goes on decreasing as we increase the number of epoch?
Yeah, very good question. Most of the cases, error does not increase.
Okay.
If your data, when you are talking about PNN, it is not increased because all the calculation are based on the equations. Means you are not giving the data. But when you are just giving it on the data, then error may become. But from when you are calculating through equation, it will not increase.
Thank you, madam. That
It
clears my
will,
doubt. Yeah.
ma'am, just listen. You are from mathematics background?
No, ma'am. I'm actually from the physics background.
No,
I
no,
had my.
you have studied numerical analysis in your
Yes,
BSc.
yes, yes, yes,
So
yes.
yes, now so in a because when I'm a student in my young age, so we don't have such type of tools, but iterations we have done, है ना? So
Yes,
in
yes.
numerical analysis, we also done iterations. If you remember, so after a certain point, the value will be constant, but it will not increase the error. Remember?
Fine,
So
fine.
if
I think I got it. So that is the difference in what. Yeah, I think you got me right.
है ना? So
Okay, yeah.
जो 5 after such a मतलब error will goes not increase after such certain point it is stable, but it will not increase.
And one more,
Yes.
you have talked about in both the examples, you have talked about linear equations. So, can this be done for non-linear?
Yes, of course. It is working for the non-linears, and it is drastically a very good for the non-linear also. This is really good because because I'm from fluid, so my equations are always coupled equations, and it is in non-linear form, always a non-linear difficult forms. Initially, it was very difficult. We used Runge-Kutta method and linearly transformations. First, we partial differential equation we convert using linear transformation to the ordinary differential equation. Then we solve it. But from this, we can take help from PNN, and it is solve the non-linear equations also. The program is too the program is too lengthy, but it is easy to solve by PNN rather than other methods. But once you get to know, well, once you're comfortable with the PNN, you start with initial. There are so many videos available on the uh, YouTube. And ma'am also shared one video. So you just start with a very small program, or you can take help
So
from
may
a.
I interrupt? May I interrupt?
Yes,
So
ma'am.
by getting acquainted with PIN, physics-informed neural networks, many of you might have already realized that having a basic understanding of Python is a must. It will be extremely helpful. So most computational tools, machine learning frameworks used in this area are based on Python. So to help you begin, I have shared my video. My first introductory episode I have shared, and I encourage all of you to spend a little time exploring it. So I have shared my handler also. So you will get all the 8 episodes. And up to library, I think maybe few libraries might not have been included. So I can give you one more video on that. So don't worry. But just start learning Python from the basic and be comfortable with coding part of it. That's why I asked her not to just ask to copy, because copying will give you nothing. When you
Yes.
understand the things that this is that, and I am at least while copying, I'm able to understand what I am copying. Then only
Yes.
it will make little bit of sense. Will make more sense if you do it by yourself. So, but in one just a little one session, this cannot happen. So I encourage you, all of you, to spend a little time exploring it. Even a small little daily practice will make you comfortable with the computational aspects we will encounter
In
during this
fact, I am
workshop.
not
So
from computers
please do.
background. I am from mathematics background, and we do
Understand that.
learn.
I could,
Actually,
I know
because you
very
know,
well this thing. So don't worry, we have sufficient material. No one
yes,
has to worry about Python. I am there, Python
yes.
expert.
So
Don't worry. I will
we
solve all your
initially,
difficulties. But
initially
initiative you will have to take. So,
Initially,
okay.
when I learned about MATLAB also, because for my PhD, I have to learn MATLAB also. So I learned it from the books. I have learned it from the YouTube was not there. I think past 15 years मैं बात कर रही हूँ. So YouTube was not there. आज तो इतना helping tool है. Chat GPT is like anything. So first we learned the MATLAB also. If you know MATLAB or any language, you can learn Python easily. And nowadays Python, I think more easy. School student also working on Python. So start initially working on Python, then you could understand PNN very fastly. Or once you understand the basic working on PNN, it will very useful for you.
Yes, thank you, madam, so much, Abha madam and Priya madam. It was
Thank
very
you, ma'am.
nice to learn something new. Thank you
There
so
is one
much.
more
I'm
doubt
done.
from the
I'm done.
participant, whether this model is suitable for higher order differential equations as well.
We have to write the different differential equation, and we have to write the differential equation in that kind. We have to change the type of. Matlab when we are typing that equation, na. So here I am writing first derivative. So we have to change in the programming only, just in programming. It will work for higher order also. No problem. But differential equation different होगा, boundary condition different होंगे, तो definitely writing will be different, but math model is working. Because
Okay.
here we are not making anything, na? Python libraries are also there. We are calling the libraries, and we are giving the equation. तो equation आप कुछ भी दे दीजिए, वो solve करके देगा ही देगा.
Yes. Again, there is one more question from the participant that will we be having some assignments or practice problems to get hands-on of the
Yes.
experiment? So I would like to throw some light upon this, that you will be having some assignments after each session. Okay, the session speaker is going to put some assignment, maybe directly into the WhatsApp group. And at the end of the 5th day, maybe on Sunday, we'll be having a short multiple choice based quiz to complete your workshop at the end. But the small assignments that you can solve using the learnings you or the outcomes which you have got through the session, that assignments are regularly will be uploaded after each session. So please try to solve the assignments and try to submit it back or ask the queries if you are not able to solve directly to the speakers. The speakers are available in our WhatsApp group as well.
No
Yes,
other
Priya ma'am,
question?
you would like to continue?
Okay, then please ask chairperson to give remarks. Call sir.
Any other question from the participants? If you have any other question, you can directly unmute yourself and ask, or you can put it in the chat box and I will read it for you.
Would be better in chat box. Let's move ahead.
Yes, so no more questions. So I can directly call upon our session chair today, Dr. Srinath, to please sum up the session. And if you have any queries, you may please ask.
Okay. I do have a small query. We have been using pins at our industry for doing aerodynamic simulation related work. The query that we all do have is we understand that machine learning requires a lot of data, pure machine learning, whereas pins is a combination of both equations as well as data set. So, to what extent can we reduce the data set for pins as compared to machine learning?
Uh, in what sense, in what scenario you are saying? I don't understand.
Okay. With regard to the number of amount of data set that would be required for training.
Uh, we don't require any data set for training in PNN. We just give the differential equation, it will learn by itself. We don't need any data set. Or if you are not having equation, then if you are taking a neural network, then you can make a more neurons, the more hidden layers are there, and there are more different type of bias, sigmoid function you introduce to find your suitable answer. I may say your suitable answer. You can use any kind of a sigmoid function. You can introduce different hidden layers. More different hidden layers are there, and you can iterate and iterate up to the 9.7 0.99 or 0.98 up to that kind of. But when you are giving the equation na, उसमें ऐसा नहीं होता है because solutions are very accurate with the equations because physics is there. Means suppose I'll explain you and I just go through your biodata and it is very hard from mine. So
Then, as a
if,
question.
so if I'm not right now, correct me please because I'm from mathematics and you are from engineering. So there is a huge difference between your understanding towards things. So I'm taking example of ball. So if you are collecting a data and at what time you are taking a data, so when you can collect a data and you predict the values, na, it may wrong or your prediction may be wrong. Means if you are having a before 100 years say petrol prices and now you want to assume the next 10 years or next 5 year or next 6 month prices, it will not work. But when you are having a equation, you model it, okay, it is working like this differential equation or it is changing up to that equation. But solution of differential equation or solution of any kind of equation give you always a correct answer. Means suppose you are throwing a ball and it is taking a point ke how may it rise up to what height. It is a parabolic type of a curve. तो उसमें कभी फिजिक्स की लॉ की हम बात करते हैं इक्वेशंस इफ वी पुट इन दैट एंड फाइनल कंडीशन दे देते हैं इनिशियल कंडीशन वी आर सब्स्टिट्यूटिंग ना तो उसके बाद वट एवर वी आंसर रिसीव्ड वी विल हैव अ करेक्ट आंसर नो आंसर विल बी आउट ऑफ द मून ऐसा नहीं होगा बॉल चांद पे चली जाएगी बिकॉज वी आर गिविंग दैट पर्टिकुलर एनवायरमेंट टू दैट सोल्यूशन कि यही बाउंड्री कंडीशन है यू हैव टू गिव दैट आंसर इनटू दैट सोल्यूशन that under that conditions. So
May I?
yes ma'am.
Absolutely right, sir. In physics informed neural networks, the governing physical laws such as differential equations, boundary conditions, these are embedded directly into the learning process. So because the model already knows the underlying physics, it does not rely entirely on the large databases, large data sets. As a result, even with limited data, the model can learn meaningful solutions, making pins particularly powerful for scientific and engineering problems where data may be scarce. So that is the thing.
Yeah, but thanks a lot. It really has been a very informative and educative session. I look forward to maybe interacting more with you as and when required and get an opportunity to work on these aspects.
Yeah.
Thanks a lot for this wonderful session, ma'am. And it was really heartening to see that you've been able to share the codes with the students, and also to Dr. Abha, who has told about the availability of the resources on the Python coding platform. So I'm sure it is going to
My
be of help
educational
to,
channel, sir.
absolutely. So I'm sure that it's going to be of help to all the listeners here. Thanks a lot once again, Dr. Priya Mathur, and for the team
Thank you,
for
sir.
inviting me.
Thank you so much for the patience listening. And I just want to say everybody can make use of it. Go to the Google and just go through some lectures or start from your side also. And ma'am के जो lecture series है, ma'am you share with the student and they will learn Python. So it will be helpful for the next also. We will look forward to for more collaboration in future. Thank you, everybody.
Yeah, and special thanks to Dr. Bhakti for her for all her efforts and for inviting me for this particular session. I
Yes,
also look forward to attending few more sessions when possible in the coming days. Thanks a
Absolutely.
lot, Dr.
Absolutely.
Bhakti.
You're welcome to attend all the sessions, sir. Definitely.
Thank you.
And if the speaker don't mind, there is one more question, maybe the delayed question,
yes.
but the question might have arrived late in the participant's mind that if we are training with equations, then how it will be compared with practical results?
Practical results we can compare through this now. There is a comparative graph also. We can give the data, experimental data, and the PIN equations, and then we can compare both the results. The PIN itself compare. We have a different code for this. You paste that code, you write that code, you give that data. वो डेटा उठाएगा उससे he itself draw a graph from that data and the PNN graph data, and it can compare which is better. Simply, very simple. And it is the utilization. In fact, first we solve the equation by finite element method. Then we solve that equation by PNN. Then we compare the data. How this way we are making research paper right now.
And that's how the equations are made. Because earlier there was practicals only, and then came
Yes.
into the picture the mathematical equations to represent those practicals. So you have to
Yes.
have some sort of
Uh,
experimentization in the
we
beginning,
can
and
also
then you can always
we can
extend to it.
also we can also augment the data also in machine learning. We can also augment the data. हम equation से data भी बना सकते हैं. So if we don't have a data by experiment we have, then we can also create a data, augmented data जिसको हम बोलते हैं. We can also create the data by the equation also. तो हम Python से वो भी बना सकते हैं. तो so many ways there are working कि बस you have to ask and everything is ready.
Yes. So if there are any more questions, no, I don't see many more questions now. So now we can go ahead with the winding up of the session. So that was really a very, very informative and insightful session. So let me offer the formal vote of thanks of this event. So just a second. Okay. So the first and the foremost, I would like to express our heartfelt gratitude to the patron and mentor, Dr. Abha Khandelwal ma'am, for her inspiring vision and mission to promote computational thinking in physical sciences. And this workshop is a significant step in the larger initiative undertaken by AACST in collaboration with IIPT RC08, aimed at introducing and strengthening the culture of computational aerospace in physics and allied sciences. At a time when simulations, data driven methods, and AI assisted analysis are rapidly transforming scientific inquiries, this workshop was thoughtfully designed to bridge the gap between the traditional and theoretical learning and modern computational tools. So, thanks to you, Abha ma'am. Then we are also thankful to IIPT RC08 for the additional support they are providing my thanks are due to Dr. Srinath for taking his valuable time and accepting the invite and chairing today's session. My sincere thanks to the speaker of the day, Dr. Priya Mathur, for a wonderful and detailed session. In spite of her troubled health, she put every effort to execute the session perfectly. And last but not the least, all the participants for enrolling and joining the session and taking advantage of it. I hope the complete workshop is going to be a fruitful learning experience for you all. So that is all from my side. And now I will stop sharing the screen and I'll ask everyone if they could turn on their camera so that we can have the photograph for the day one collectively for including all the participants, speaker, everyone. So I request everyone to please, yes, turn on your cameras. I have put the grid mode on so that I can see all the people who are right now online, joined together from different parts of the country. So that's so nice to see the learned faces of gathering over here. So just let me take few glimpses. Hold on for a second. Just one more.
And smile, please.
So yes, thank you so much, everyone. I request the speaker of the day to please put the assignment in the WhatsApp group as soon as possible. Once she is ready with the assignment, she can put it in the group. Also, she is going to share the PPT and the code files to practice the for the participants at home. And the test will be there on Sunday. Don't forget, the participants. You are supposed to give the test at the end and try to complete the assignments within the stipulated time. If you have any doubt, the knowledge-full persons are there in the group, so you can always ask. Okay, Abha ma'am is always there to clear out your doubts, I'm sure. So thank you one and all, and have a great evening ahead. Thank you.
Thanks a lot, everyone. Bye.
Thanks, sir. Bye.
Thank you.
Thank you.